So when you are creating the triangle objects, we discussed that you need to compare it with respect to area. So there is a compare method in the comparator interface. And when you want to implement it for your particular class, then you will have to implement this interface. Now, once you implement this interface, it will give you a compare method. Now that compare method you can implement on your own. So since it is your own data structure, let's say triangle, and you have certain attributes, then you will compare it based on the area. So in the compare to method now, this it will have a compare method, the comparator, if you after you implement this interface, you will implement it depending upon which object or depending upon which attribute you want to have the comparison. So in our case, let's say if we want to compare it based on area, then you will have to mention that. So if you are passing triangles, then based on area you want to compare. So here there are different comparison methods. So we can see here the methods are different, but you can do something similar. So if you look here, so one method is again so this is a comparator interface that you have to import. After you import, whichever class you are doing the comparison, that class has to implement that interface. Then only you can use it. So in that, maybe yours a geometric object or triangle, so whatever is that data type, and how you want to keep those objects. Now, the compare method, you're basically going to pass two objects. So maybe in your case, if you are still going to pass geometric objects or triangle, so once you pass those objects, now you are going to pick that attribute based on which you want to do the comparison. So here, if you say we are going to use the attribute of get area, then it is going to sort it based on area. If you just give compare area or compare triangle one, triangle two, it will not do the comparison unless it knows based on which attribute you have to compare. So here it is returning O1 get area greater than O2 get area. If so, so this is a kind of if else. So if the first object's area is greater than second object's area, you return 1. Else, if they both are equal, you return 0. Else, if second object's area is greater than the first, then you return -1. So now this is the implementation of compare method, and accordingly, you can use this comparison in sorting also. So in sort, you can pass the list, comma, whatever comparator method you are using, and then it will call, and based on this compare method, it will do the comparison. So let's see this here. So I think here they have done it based on area only. So finding maximum of these two. So you created two objects, geometric objects. One is a rectangle, one is circle. And then we have to pass whichever area is maximum out of these two. Now again, how are we going to compare? We are going to call the comparator method that we just saw. No, I think they have implemented here comparator method. And in this comparison method, again, you are going to compare C.compare. So whenever you are taking the comparator interface, it will have its own compare method. So you can basically override that compare method depending upon which object you want to compare. So sometimes you might want to compare based on area. Sometimes, let's say I want to compare based on sides and so on. So here the area, greatest area is G point get area. So here after comparing, again G1, G2, if it is greater than 0, so generally it performs G1 minus G2 if it is integer value. If it is string value, then it will, in string, there are two different types of comparison. One will be based on length, one will be based on alphabets. So here it is just checking the integer values. And if G1 minus G2 is greater than 0, then you return G1 as the maximum object, or if that is not the case, so it is if else. If that is not the case, you return G2 as the maximum or as the bigger object, and whichever is the return value, that we say the larger object is. So you might think of something similar when you are going to sort the triangles based on the area of the triangles. Then in a newer version of Java, now you don't necessarily need to implement lambda expression, but the lambda expression is also added, I believe, after JDK version 8 and above. So you can use, this is a third possibility which you can use to compare it. So in this case, they have used two sorting of string by length and sorting of string depending upon the number of letters the string has. So we'll also have a look at these two. It is opening. Here it is sort the string by length. So again, here it is a sort string by length class, and let's say several cities are given as part of the string. Now string class, we can directly use the arrays.sort function from collection class. So this function is there in the collection class. And in order to use that, you have to pass cities, and then you have to pass what is the comparison criteria. So you are creating the new my comparator. And here it is just printing all the cities, let's say. Now, again, it implements the Java util.comparator. That's what I was looking for, how it is not imported. So I believe they used it here. So instead, you can also import this comparator and then use a comparator string. And here you are basically to sort going to use the length. So s1.length minus s2.length. So if first string's length is greater than second string's, then that is the bigger object out of two. And then using sorting, you are going to use the same comparison. So it is going to, let's say if we run this, it will now sort based on the length of the strings. So this has a smallest string, this has a bigger length, this has even more, and this including space, this is the bigger string. So something similar. So in the comparator, basically when it uses, so it is using this comparator wise sorting, and you notify what criteria you want to sort. So it is string, so you might sort based on the length of the string. So where you have to give some criteria. What is the criteria to decide a bigger string? So if the string has more length, then that is bigger. So you have to give in the compare method, you have to give the criteria for a bigger object, and then it will use this comparator to sort. Now, another thing we saw that in the string, we can have a second way in which we want to sort. So maybe we can also sort it alphabetically. So if you want to sort this link alphabetically, so ignore case, but we want to sort it alphabetically. Now again, here we are using the arrays. So again cities.sort, but now we are using a different comparator. So this is called as a lambda expression. So again, when you are comparing S1, S2, and this is part of lambda expression, it tells us that S1 dot compare to ignore case S2. Now, depending upon the values it returned, true, false, you know that S1 is greater than S2 or S2 is greater than S1. So I believe again it returns 1 when S1 is greater than S2, returns 0 when both are equal, return -1 when second string is greater than first string. So this is a lambda expression. Again, we can do it without lambda expression also. So basically, it is kind of a short form. Now if you want to do it without lambda expression, we will again have to mention it into the compare method of comparator, and then we can sort. So here they gave the basis of sorting, and using the sort method of collection, it is sorting based on now the I think this is based on the alphabetical order. So if you do that, you are ignoring case, but it is in the alphabetical order sort. So now our sorting first, we will have Atlanta, then Dallas, then New York, and then so on. Again, some simple programs, but it will be useful for implementing your own project. So here is another example where they have one data structure known, and it has three different attributes, maybe 5.5, 10, 100. Then by default, if you're giving on basis of which attribute you want to compare, then you can also pass arrays.sort, the list which you want to sort, and then the criteria or the compare method you have to mention in the comparator interface. So this is a collection class we saw a little bit in the last class. So that was the main class. Now here we have a java.util.collection class where we can sort, we can binary search. So if we take a list of all numbers, let's say from 1 to 10, and we use a binary search, pass the list and number, then it will give us the index. So it will, the return type here is binary search list and key. That will search it and give us the index. Then it will also reverse the list. It will sort in the reverse order. So if we use reverse order, it will shuffle the list, it will make it random, or it will copy the list into another list and so on. So those are finding maximum is also possible from that list. Finding minimum is also possible. And again, if you want to find frequency, how many times a particular object appeared in that list, then it can also return the number of occurrences. And again, if two collections are given and we check disjoint method on the collection, then it will check and return true if they don't have any common element and so on. So maximum functions, or you can see we do use max, min, binary search. Now, if we want to use binary search, the list has to be sorted. So if the list is not sorted, then binary search will not work. So here is one example where you have ball object and then maybe I think this is 1 to n and 1 to 1. And then you have created an object of ball having. So we didn't see Java FX yet. So we will see those are, I believe, from chapter 15 to 20. Maybe we will see those later. Right now, I will skip this example. Now, if you remember the very first diagram that we saw here, in the collection, we have three basic types: set, list, and queue. And up till now, we were mainly discussing about list, then array list, linked list. Now, if you look at vector is very similar to array list. But in this case, the values are synchronized. So if in an array list, you are trying to you're trying to add any value or you are trying to retrieve index for something, then it is allowed to do that together. So kind of a different threads are doing that, and which is allowed. But in vector, it is synchronized. So kind of a they don't really allow operations happening at a time. So we are not really using vector as such much, because in vector, what values we are entering are entered in the sequential manner, but we are not accessing it as per the index like in array. So particularly when we are using a dynamic array, we want to use that the array should increase or the array should decrease. Then in that case, mainly we are using array list. But when we are using stack, then in that case we are going to what you can say inherit vector and then create stack as a child of vector. So whenever we are creating stack, so we don't really have to do it. It is internally the structure is in place. So when you say stack S is equal to new stack, it automatically takes the properties of vectors and it uses some functionality which is already there in the vector, and on top of that it will have the added functionality that a stack should have. So if you think about some differences, so since we are not really mainly going to use vector and array list as such, but there are certain differences, and so both are dynamic in nature. So meaning that if you want to increase the size, it gets increased in array list. You don't have to fix the size like in case we do in arrays. So on the background, it is happening. So if the array limit is over, it will increase the size. We saw in the array list, it is generally if original size was n, next time it becomes n plus n by 2 plus 1. In vector, if your original size has reached, let's say you have initially the size of 10, when it is over, generally it is doubled. So it is twice n next time. So all entries, n entries are copied into the new vector, and then we continue. So we are not really doing anything. So all those things are getting done on the background. So this vector allows for synchronization. So it checks that the value is available, then only it gives access. Whereas in array list, we don't really check. And for whatever functions we are using, I think mostly we will use array list. So there are some differences. Now, if you look at so we can replace array list by vector, but if we are doing that, then we will not, it will have its own synchronized method. Again, we can sequentially enter values, and it is generally not so efficient for most of the applications because we are not retaining the index. Now, in case of stack, it is fine because we know that stack, we are going to look at stack as some kind of entity or data structure where one end is closed. So this end is always closed and we only have one end which is open. So whatever values we are entering, we are only entering from one end, and we are also taking out the values from the same end. So in this case, we are not really retaining the index of values. So if we are entering, it is like keeping a stack of dishes. So we are keeping 5 dishes, then if I have to take out the dish, that will be the last entered dish. So the very first entered dish will go in the bottom of the stack. So this is, let's say, my dish 1, 2, 3, 4, 5. So the functionalities are not as many functionalities as array. So if you want to insert anything at location 2, can we insert? So like how we did it in array list, we have add method, add at index 2 this value here. If you are looking at stack, So this is a stack, okay, and we are going to implement it with vector. So if we are looking at stack, there is only one open end. So there is no way we can reach at plate 2. So we can't reach at this. So if we have to enter something at index 2, we really have to take out all the plates and then put something at 2. So that operation is not possible with stack. With stack, we can only put more values, which is called as push. So entering values. Now, if we push integer values, let's say first we push 10, then 15, then 20, then 7, then 12. So let's say we are pushing integer values in this. Again, we don't have any say on what index the value will have, or we don't have any say on which index we want to enter this value. We will just keep on entering from only one index. And when that is called as push operation. So when I say push 17, it will go and the next value will go on top of 12, and that will be my sixth value. Then when I say pop, that is another functionality that is available. So whenever we say pop, the last value on the stack will come out. So every time, since we cannot reach to any intermediate values in the stack, it will always be whenever you are popping or deleting, you're always deleting whatever value which is on the top of the stack. So the pop operation is kind of a synonymous to delete operation, and push operation is synonymous to add operation. Again, we basically have only these two main operations, and then third operation is peek, where we want to just see what is the value at the top of the stack. So that is a peek operation. So if I say peek here, which value can we see? So if we, for this stack, if we give peak value, we are going to see 17, okay, because that value is at the top of the stack. Any value we are going to push, that will come on the top of the stack. So stack is also called as last in and first out data structure. Because whatever value goes in last, that value comes out first in this data structure. So basically it is derived from the vector class, or it is a child class of a vector class. So let's see, those are the functionalities available for vector class. So you can create a vector with initial capacity of 10. And again, it extends the collection class. So you can add element, we can check the capacity, you can set size, trim size, first element, insert element, last element, and so on. So when we implement, so those methods will not be there in stack. Remove element and this position, or remove element and this particular index. Those will no longer be available to us. So stack, we saw it represents last in and first out data structure, and these are the functionality of stack class. So we will see that there are very limited functions available for us. So we can create a stack. So that is a creation of object, kind of a calling constructor. Then isEmpty function, that is a Boolean function. If we have created a stack and we didn't insert anything in that stack, and then we check isEmpty, then this function is going to return value true. Then peek, it is going to give us the first, or it's going to give us the top element. Now the difference between peek and pop is that peek is only going to give us 17. So if I run peek function on the stack, it is going to give me value 17, but it is not going to remove that value. But if you say stack.pop, it is going to remove 17. And if we do pop, then my stack will have all the values except 17. So that is the difference between peek and pop. Push is you push the element in the stack, and then search, it returns the position of specified element in this stack. So basically, very limited functionalities we have out of the functions that a vector has because of the last in first out structure of stack. Now, if you look at explain that there is no priority queue, you can see that. So if we have, let's say we want to implement so let's assume we have implemented a stack. See. So here we also have to give the data type, what data type. So let's say we are creating integer stack is equal to new stack. And in the stack, once we create it, we can push elements. So we can say push and let's say 12 s dot push 9. So if we take, so how the stack will look like. So after first push, it will have one element 12. Then when we execute the second push, it will have two elements 12 and 9. Then after third push, and 12, 9, 20, and in the end, it will have 12, 20, and 50. Now, if we say s dot peak, now in that case, this particular statement will give me value 50. So 50 will be returned, but no change in the stack structure. So it is only going to give you the value which is at the last or at the top of the stack. So when we implement it in C, mostly we use it as top function, but now in the already defined structure, we have the peak function. So we are going to use s dot peak. Now, if we say s dot pop, what is going to happen if we print that value is going to be 50, but that 50 is no longer on top of the stack. Since we have removed that value, now my stack will look like this. Second time, if I say s dot pop, after executing this, now my stack will look like this stack, because now two elements from the stack are gone. And if I do s dot pop again, then I will have stack similar to this. If I do it s dot pop again, now what will happen? I will get a stack which is empty because I inserted 4 elements, say s dot push, and now I pop all the 4 elements, so my stack is empty. And now if you say s dot is empty function, I don't know, it is empty. Okay, empty function s dot empty. So this function will return true at this time because now my stack is empty. So if you say some Boolean variable
is equal to s dot empty, and that will give me value true. If in between, if you run s dot empty function, that will, or s dot empty method, that will give you false value when the stack still has elements in it. And another so mainly we will use those, the push, pop, pick, and empty. So those are the main methods that we will use when create an object of a stack. So when you go to a data structures class, maybe this objects you will implement on your own. So when we say linked list, you create your own small data structure of a linked list, and then you say, oh, it has some data and it has a pointer to the next element. But in this class, we are going to use the already existing library, and then we are going to create data structure and check using all the functionalities of that data structure. So in Visual Code, it should, when you say queue, it will show all the functionalities of queue or stack. Now queue is a similar data structure, but now we have a structure like the queue where people are standing in the line. So whoever goes there first gets the work done first. So it is, this is also called as first in, first out. So it's a fair treatment to all. So whoever goes there first gets work done first. And similarly, the elements are also arranged in the same manner. So whatever is your first element, that gets deleted first. So if I have a queue of 5, size 5, and if you want to, now again, let's see the functionalities of queue. So offer. So offer is again similar to add. Similar to add. Pull is retrieve and remove head of the queue. Then there is a remove function. Then there is a peek function. Peek will again see what is the next number to be get removed if we remove it. And element, if again what is the element, but it does not remove the head of the queue. It just retrieves whatever is the element. So if we if we want to enter elements, we are going to use the offer method. And again, if you want to implement queue, you will have to use java.util.queue. So now once we have queue, we can create an object of queue. And I think we have to pass the data type. So integer queue is equal to new queue, and here it will create an object queue. Now you can do all the methods on the queue. So if you say queue dot offer and you insert 12, then 12 will get inserted at the first position. Now if you say queue dot remove, it will remove the very first element whichever entered first. So now 12 will get removed. So let's say after 12 you say queue dot offer, and offer, if the queue is full or you cannot enter, then it will return false. So as long as the queue has a capacity and you can enter the value, this queue.offer will return true. And then let's say next element we inserted 8. Then let's say queue.offer 10. Q dot, so semicolon, then we write programmatically. Q dot offer 29. So 29 will be the next number. Now, if you say Q dot remove, it will remove the first element which was entered, which is 12. So after Q dot remove, now our Q will have 8, 10, and 20. So here we do not have any priority. Whichever element comes first, that element gets out first. And now suppose there are certain people who need to be given more priority. So for example, there is a line and president comes, and then we want to give the special treatment to them, and maybe we want to get their work done fast, or people who have higher priority or processes who have higher priority. Then in that case, we want to use something called as priority queue. So in this case, it will be decided based on the priority of elements. So not just the first in, first out order, but on top of that, there will be something called the priority for every number. So here, okay, first element Q will be, you will be removed. Then next time when we say Q dot remove, next number will be 8, will get removed. And now our Q will have only two elements, 10 and 29. So again, if we keep on removing next element, if we again say Q dot remove, it will display and the next element removed will be 10. And in the last time, if we again execute Q dot remove, then that time the last element 29 will get removed. So the same sequence in which the elements go inside the queue, that will be the same sequence in which elements come out. So generally, the end from which the elements are coming out is called as front end. So when you remove 12, well, is the first element to come out. So that's the end to come out. So it is called as front. And the end where it is new element is added, that end is called as a rear end. So in queue. In stack, there is only one end, right? From where you will add the elements and remove the elements. And this is called as a top of the stack. There is only one end for the stack, but for queue, it is front and rear end. So peak we saw, and at any time whenever we see peak, whatever is the element at front, that will be displayed. So if this is my queue, and if you say q dot peak, that is going to return which value it will return? 10. So it returns the integer value since the queue is of integer type, but it will always return the value which is the next to be deleted, but it will not delete, it will just tell us. So sometimes we want to check if we really want to delete that value or not. So we can run q.peak and then check, okay, this is the value at the front. So whether you want to delete it or not, so depending upon that, we will use the q.remove method. Now there is another data structure deck, so we will come back to it. So this is a priority queue implementation. So let's look at this. So now instead of just queue, we are using the data structure priority queue, and then we have to tell which elements we want to store. So like in case of stack, we said stack integer or queue string, then we will save all the string values in the queue. So basically any data structure we can save in terms of stack or queue. So if we are creating priority queue of type string, and we are going to name it as a Q1, where it is our new priority queue, and first element to be entered was Oklahoma, second Indiana, third Georgia, fourth Texas. So this is our queue. Now we are going to print the priority queue using comparable method, where if q1.size is greater than 0, we are going to remove the values, and then we are going to, so here we are not basically doing anything, whatever the queue is. So how will our queue look like in this case? Oklahoma, Indiana, Georgia, Texas, that is the order. And if, as long as we have values in the queue, we are going to remove items one by one. So the first q1.remove will remove Oklahoma, second will remove Indiana, third will remove Georgia, and fourth will remove Texas. Same order we will see all the values. Now we want to change something, and we created a new queue. Now this new queue, we want to do it separately, where we want to reverse the order. So we want to get the queue in the reverse order. So now if we have Q2, whatever values are there, those should be printed in the reverse order. And then instead of Oklahoma, Indiana, Georgia, Texas, we should see the reverse order. So if you run this here, you will see that the priority queue using comparable. So here using comparable method, so it did use the comparator internally. So you will see that the very first time it used the alphabetical order comparator. So I believe it is already there. It is already there in the util package. So for string, so the default comparator for string is alphabetical order. If you want to change it for size, then we have to write our own. So this is the priority queue using alphabetical order, and this is the priority queue using the reverse order for strings. So collections dot reverse order, that will give us the alphabetical order, but in reverse way, meaning that the largest number. So in ABCD, T is the value which comes the last. So in reverse order, that will come first. Then O will comes in the alphabetical order. So if we are coming from Z to A, so that is the reverse order we are getting for this queue. So you will see that the queue here, although if it is a normal queue, it will be printed Oklahoma, Indiana, Georgia, Texas. But now we are using something else, and then depending upon alphabetical values, or depending upon if it is a number, then it will sort. We should be able to sort it in ascending or descending order. So priority queue, capacity, and then comparator. So if we do not write our own, then it will use the default comparator. So for strings, it is alphabetical order, and for numbers, it is again ascending order. If we want to change it, then we have to write our own, or we have to give if we want to reverse that order. So this is a
So if we have the numbers in a priority queue, it'll remove like the least number first.
yes. So it will if we are using the comparator here, so they have used the default comparator. So it will use the ascending order. And if you do it reverse, then it will do the reverse order. So here is another stack function. Maybe we can see that. So now we are going to go to the next chapter, which is about sets and maps. So if you remember the sets in discrete math 2. So again, that is a part of, so we saw this part now, list, queue, priority queue, linked list, array list, vector, and stack. We still have to see set, we still have to see hash maps. So if you look at set, again, there is a interface. So a set is, I think this is an interface, and then you have abstract class, abstract set, and then you have two different types of set, hash set and linked hash set. So as the name suggests, there is some kind of internal hashing here, meaning every element of that set gets a generated hash code. And then depending upon that generated hash code, you can search the numbers faster. So if you look at the collection interface we saw, so those are the basic methods which are also applicable to sets. So it does not introduce any new methods or constants, but it will be arranged in such a way that no two values are allowed. So if I create a set S, so it will use all these methods, but little different way. So if I use set, let's say we created integer set and S is equal to new set, or maybe we can, so that is the hash, sorry, that is the abstract interface. So we are going to create an object of hash sets, new hash set. So if we create a new hash set S, now we can apply different methods on it. So if I say add, we can add integer values. Now, if you remember the set from discrete math 2, then a set can have different values and in set. So there are two distinguishing factors in set. One is that when we talk about set, there is no repetition. So the set values we cannot repeat, and then there is no order. So order is not retained and repeated values are not allowed. So if I'm saying, if I want to insert values, what will happen? It will insert the first one, then it will insert 4. Then it will insert 2. Now what will happen at second 4? It will not insert that value. It will say that this value is already there in the set. So this value, repeated value will not be inserted. Then next value comes 3, that will be inserted. Next value comes 1. Again, 1 is already there in the set. So the value 1 will not be inserted. 10 is a new value. So we are inserting. So if you remember in the set theory, we saw that if you have set 1, 5, 3, then that is same as set 5, 1, 3, and that is same as set 1, 1, 5, 5, 3, 3. So only it means that 3 is a member of that set, 5 is a member of that set. So every value is unique in the set. So whenever we are adding, it will manipulate it accordingly. So if you are entering a repeated value, it will not store that as a new value. So when we are going to create an object, we are going to create an object of hash set class. And again, it will extend the collection. So it will, we can say, implement all the methods of collection class. So it will have some initial capacity, and then we can add values in it, we can remove values in it, and so on. So all the methods we can use: s dot add, s dot add, or it will get added. When I say s dot add 1, again, it will not get added. So my sets will have all the distinct values. When I print that set, every time I might not retain the order. So once it might get printed 1, 4, 2, 3, 10. Second time you might see 3, 2, 4, 1, 10. So the order is random. The order is not stored. So only these two differences from array list is no repeated value and no order as such. So we saw that for set class, the abstract class is abstract set, and it extends from collections and implements set. So it provides some additional methods like equals method and hash code method. So hash code is sum of hash code of all elements. So it is kind of a internally generating a code, which is making sure that if that code is same, then it will not have another value having the same code. So Now hash set is the one we are actually going to implement, we saw, and we can implement all the methods in the hash set. So let's have a look at this hash set program. So you will see that all the other methods are pretty similar. So you are creating set. Now they have created it with string data type. We can as well create it as integer set. They have created a string set and simply say new hash set. Now again set.add London, Paris, New York, Beijing, San Francisco, New York. So the final value is same as the third value. So twice we are trying to add the same value. So if we print it, you will see that only once the value New York will be accepted. And here is another iterator way of hash set. So you say that N for now this is a string type. So you string S is going to access all the values in the set. So you are mentioning the set and then whatever string. If it would be an integer set, we will say for int value, you access it throughout the set. And if I just say system.out.print, it will just print it as it is without repetition. Now here they are also changing it to uppercase. So without repetition, all set values we should be able to see in uppercase. So system.out, and this is another actually same thing. They are also doing it with iteration with for each method. So for each element, you print that element and make it lowercase and then print. So first make it uppercase, then make it lowercase. So if we compile this, you will see that first all those elements. So you see that the order is not maintained. So first, what was the value? First entered value was London. Now we are seeing San Francisco. So if you execute it next time, you will see a different order. So the order is not maintained. So our original set was this. So New York is not repeated when we converted into upper case and when we converted into lowercase. So again, very similar to array list with only these two attributes additional. Can